Frode, you flew in from Norway, but I heard you already yesterday went to Tampere or somewhere.
Yeah.
So you didn't fly only for this, which is always good, of course, practical thing to use.
Yeah, I had the opportunity to combine the two events.
To other meetings and stuff as well. Great to have you physically here in our studio as well.
Thank you. Nice to be here.
So Frode, could you tell us shortly before your presentation what your role in EDRMedeso is and how that connects to Industry 5.0?
Yep. So I'm CTO, the Chief Technology Officer in EDRMedeso, and I've been responsible for our IoT and Industry 4.0 development for a number of years.
And how big a change is this?
For us,
put it into perspective.
Yeah, for us, it's not that big of a change because I think we actually did Industry 5.0 when we called it 4.0 because our concept is focused around getting engineering knowledge and insight and competence and experience into the solutions, not just pure data.
But Frode, actually, be honest, Industry 4.0, 5.0, how much is it in the worst case only about semantics? Because I guess it's a bit of a buzzword as well, so you could say that, huge change from 4.0 to 5.0, but...
I think it's an evolution. It's a gradual transition from 4.0.
Yeah, you can't really draw a line there.
Oh, I don't think so. I don't think so, no.
That's a good, honest answer. Hey, you come from the engineering world, of course, as we now heard and know. So product design and development, what's the status for the use of AI today, which is, of course, we just talked with Sami about it, a huge shift and very exciting future in that regard. Yes. So is that blooming just like sort of chat GPT?
Yeah, I don't think it has been implemented that much.
So still baby steps.
Yeah, still baby steps. I think the industry is curious, but not implemented into their processes. It might be because the solutions are not mature, but yeah.
Yeah, but the largest potential in that case for AI in the engineering space, what should we what sort of space should we be watching?
I think we should be looking for at least two things. One is the fact that engineers are spending a lot of their time on repetitive tasks, which could be automated by AI, not to remove the engineers, but to have them do more valuable activities. And the other one is to retain IP. You can put all the knowledge in the company into an AI model rather than having it floating around in the company in an unstructured way.
Frode Halvorsen, great to have you here with us. And now your presentation, AI for Engineering, leveraging deep learning to accelerate development cycles by 2 to 10 times. Did I read that correctly?
Yeah, you did.
Okay, good. It wasn't that more cryptic. So it's all yours.
Thank you. Thank you, and welcome to this talk about AI for engineering. In today's talk, we will give a brief introduction to how some existing technologies and solutions can help you speed up some core engineering, design, and product development processes with as much as 2 to 10 times. In the most extreme cases, even more. So one of the underlying challenges that we will address is the fact that engineers spend a lot of their time on repetitive, maybe low-value routine tasks. And such tasks are obviously very, very good potential for AI. Some studies indicate that maybe as much as 30% of an engineer's time is spent on such tasks. So there's obviously a quite significant potential here. In today's talk, we will also address 3 quite important business challenges that we see among our customers today. The first one is the ever-increasing need and requirements on improved product performance, and the fact that the product performance needs to be considered and addressed earlier in the design process and in the concept evaluation process. The second challenge we will address is the fact that companies need to get quicker to market, have a shorter time to market, and one blocker in that process is the design cycles. Companies need to reduce the time needed to do design iterations. And then the third business challenge we will look at is the potential knowledge loss. How do we make sure that all the experience, the knowledge that our company has in our brilliant minds of the employees and in the data that is being stored everywhere, how do we retain that and make it reusable? So those are three key business challenges that we will try to address in this short talk. To do this, we will have two technologies helping us. And the first one is neural networks. And I mean, neural networks are everywhere today, and they might seem a little bit scary. But I would strongly encourage you to challenge yourself a little bit and try to look behind the curtains and understand how it's actually working. And it's not that complicated to understand the basic concepts. And I think that would be truly interesting, as it will be an important and significant part of our lives the coming years. The other kind of more new concept maybe that we will use to solve these business challenges is the concept of synthetic data. In the first phase of AI, it's been driven by real data, meaning data that you collect and that you store and you manage and use to build your AI model. Synthetic data, that's all about data that can be generated. It could be artificially generated, for instance, by numerical simulations, statistical models, or first principles. So kind of the large players like NVIDIA here, referring to Gartner, shows that in the coming years, synthetic data will completely overshadow the use of real data in AI models. And that's kind of a big opportunity for a lot of us. That means that you can create the data that you need. You don't have to have a system in place for collecting large sets of data to be reused. So this is a big opportunity. So in this talk, I will focus on one solution called Neural Concept Shape that allows you to do all of this, to build AI models on synthetic data that can speed up some of these core engineering processes. And in a few words, how it's working, it is that you can take all your previous designs, the simulations, the experiments, the tests, and the outcomes that you might have, and the ones that you will have for the future, and feed it into an AI model. So you can build an AI model based on everything that you have done and everything that you are doing in your product development and design processes. The advantage of that is that when you then have a new design that you want to evaluate, a new design cycle, you can throw it directly at the AI model and skip a lot of the time-consuming processes that involves preparing the model for simulation, building a prototype for test, all these steps that takes a lot of time in the product design and evaluation process, and jump directly to getting the quantities that you are interested in your product for your product evaluation instantly in milliseconds from the AI model. And these are data that and results that it would usually take hours, days, weeks, or even months to get. So in this case, the speed up is even much more than 10x. The interesting question is, okay, what's the business benefits from this? And one of the challenges with the way that we do product development today is that it's a time-consuming process. You need to come up with a design, and as discussed, you need to prepare it for simulation or experiments, and then you can get the outcomes from that. You need to evaluate the outcomes, you need to revise the design, and so on. So each design cycle is time-consuming. And that limits the number of designs that you have time for any practical purposes to evaluate during your product development project. With AI, you have a pre-trained model based on all the experiments, the tests, and the outcomes that you have done in the past, both the ones that were successful and the ones that were not successful. And with such a blinking fast model, you're able to, in a very, very short amount of time, evaluate thousands or even 100,000s of designs if you automate it. So with that, you can complete and compress the design cycles significantly. And the result of that, what is that? The result is that you will end up potentially with a better design at a shorter time than doing it with the traditional methods that we're using today. So you get kind of the best of two worlds. And in addition, as you can imagine, these AI models will contain all the knowledge and the competence and experience and outcomes that you have gathered through your previous processes. So you're collecting all the IP, and it's very easy to make an AI model accessible to whoever could benefit from it. So you're making your AI, your IP, accessible to the company in a completely new way. So the real interesting part here is, how can this be used? How is it used by the industry today? So the remainder of my talk will be 5 or 6 high-level explanations of use cases that are out there and operating at the moment. The first one is connected to battery cooling systems for electric vehicles. Here, the suppliers typically have a base design that they use for their product for battery cooling, but each customer typically have a different set of requirements, which requires that the base design is adjusted to that. That could be a very, very time-consuming process to do that while making sure that the performance is as expected and as needed. So this company, Mubea, they took a neural concept shape, built an AI model that was very, very accurate. And they were able to integrate that into the designer's workflow and give the designers a tool that allowed them to, in real time, evaluate many more designs in a short period of time, and then compressing the design cycles while maintaining the product quality and delivering on the expectations from their customers. Another case, kind of similar industry, is from Bosch, that has been struggled to get optimization into their designers' hands for a long time, because the previous tools and methods were time-consuming and being kind of a hurdle for the designers to use. With neural concept shape and the AI approach, they were able to implement these tools and get it into the design processes and in the design cycles within a few months. And then it was, in this case, utilized to optimize the housing design for their electrical motors. Another area where we see a lot of use of AI and potential for AI today is in the heat exchanger business. Designing a heat exchanger is actually very, very complex. There are so many parameters that you can vary. There are so many concepts that you can explore and design that it's almost impossible for the human mind to do it. On the other hand, it is perfect for AI, because AI is really good at exploring huge design spaces fast. So here, this company that we're developing heat exchangers for aerospace applications, where performance is key. They trained an AI model first to make sure that it's giving acceptable or even really good accuracy of the simulation results and of the predictions. Then they use it to explore a completely new design space. They use AI to optimize their design. And the result of that is that the AI was able to combine different concepts that were disconnected in the past and create a new solution that the engineers had not come up with. So they ended up with a completely new heat exchanger design, giving a performance higher than any other product that they have developed in the past. This would not be possible without the AI solutions. Moving on to a completely different application area, electromagnetic actuator design. And for those of you who are familiar with such products, you know that kind of just small changes in the design, kind of the geometry, for instance, will give a huge impact in the way and change in the way that it behaves physically. So it's challenging to control the behavior. At the other hand, the customers of these companies that use these actuators, they have their own set of requirements. So every product needs to be customized to the customer needs and requirements. That leads to very, very challenging design processes. So this company, Miniswiss, they created an AI model with neural concept shape and achieved an extremely fast design iteration process. Having that, they were also able to explore a much, much larger design space than what they had in the past. They were able to find designs and optimal solutions that were merely impossible to discover with the traditional design processes. And on top of that, they reduced the cost and the time of their R&D development phase. So they also kind of got the best of both worlds. The final example that I will show today is about PCB design at a large phone manufacturer in the US. They have the challenge that they have several phone models, and each phone models has several PCBs, and each PCB needs to be optimized. It needs to be optimized on many aspects, but among other things, on where you place the chips on the PCB. One of the really time-consuming validations and tests that needs to be done for that is a drop test. You may have to make sure that the phone is working, even if you drop it on a hard floor. And that's a time-consuming process that needs to be tested either physically or through a simulation. But also the simulations are time-consuming. So that is limiting how many design they can explore and how good they can optimize the PCBs. Luckily for this phone manufacturer, they had a big database of PCB geometries and drop test results, both successful and unsuccessful, and they used those to train the AI model. And with that AI model, they could speed up the design process significantly and achieve more optimized designs. So the main takeaways that I want you to take away from this talk are the following. AI is here and is ready to enter the engineering space. Commercial solutions are available, and when applicable, they can significantly speed up some of your core engineering processes. This is potential game changers for you, your customers, and your competitors. Collecting data is not needed in the same way as we saw for the early phase AI. Synthetic data combined with all data, if you have it, can do the trick. So you don't need to have a big process up front being ready to collect, manage, store, and contextualize your data. The synthetic data can be fed directly into the AI models. And finally, as you have hopefully seen from these application examples that I've shared, AI doesn't care about the application area or about the physics. So the same technology can be utilized across your engineering team. If you set up one group that is working with developing and maintaining these AI models, they can support your electronics team, your mechanical team, and your fluids team if you have all of that. And that concludes my talk. Thank you so much for your attention.